Hello, everybody. Welcome to our first asynchronous lesson for geometry. We're going to take a look at relative sizes of angles, lengths of sides, stuff like that. And it should be pretty quick and easy. So let's just dive right. All right. Yesterday we saw the triangle inequality. If any of you were not in class and didn't check the notes, in a triangle, the two short sides have to add up to more than the third side. And that's the basic lesson. If you weren't here yesterday, you should go back and take a look at the notes from yesterday. If you were in class yesterday, let's move on. Ranking sides and angles. We're going to talk about the lengths of sides relative to opposite angles, which means we need to talk about what it means for angles to be opposite. If I say which side is opposite angle C, well, angle C is down here. The side that's opposite on the other side of the triangle, that would be segment AB. Segment AB is opposite angle C. Segment AC is opposite angle B, and segment BC is opposite angle A. It's the one on the opposite side of the triangle. And what we learn is that when you are naming the sides, we can call them AB, BC, AC, but sometimes you'll see that the opposite side is just named with a lowercase letter, side C, side A, and side B. I don't really like to do that very much in geometry because then it gets confusing talking about B. Am I talking about the side or the angle? So I'll just usually refer to them as segment AB, angle C, segment AC, and stuff like that. All right, here it is. For all triangles, every single one of the triangles, the longest side is opposite the largest angle. The shortest side is opposite the smallest angle. I've got a big angle up here. That means my longest side is going to be the one that's opposite that. And then over here, I've got this nice small angle, an acute angle, which means the shortest side is going to be the one over on the opposite side. The shortest side opposite the smallest angle, the longest side opposite the biggest angle. And that's really it. So if I give you a diagram that looks like this, and I say rank the sides from shortest to longest, well, the shortest side is going to be the one that's opposite the smallest angle. In this case, the side that is opposite angle Y is side XZ. Segment XZ is the shortest. The one that's the longest is the one that's opposite angle X. The biggest angle is 111 degrees. So the one that is opposite that is the segment down here at the bottom, segment YZ. That's the longest, which means YX must be the one that is in the middle. 44 is between 25 and 111, so that segment will have the middle length. And if we go backwards, it's the same thing. If I know what the side lengths are, the smallest angle will be opposite the shortest side. So the angle XZ is only 31. That means angle Y will be opposite that. Well, the way I've got these angles named with 3 letters, the one with the vertex of Y, XYZ, that's the one that has Y as its vertex, opposite the short side. The one that will be largest is the one that is opposite the longest side. So 73 is our longest side. The angle opposite that has X as the vertex. Angle ZXY is opposite the longest side. And so the one that's left is in the middle. So ranking from smallest to largest according to the sides that are opposite those angles. If I don't give you a diagram, well, make your own diagram. This is easy. I'm not going to pay too close attention to making it look exactly perfect. I just want something to look at so I can see which angle is opposite the sides. So I'll label the vertices J, K, and L. JK is 15. KL is 17. And JL is 12. And now that I've got this to look at, it's easy for me to figure out the largest angle, even though I just kind of drew it without thinking too hard about it. The largest angle is opposite the longest side, 17. So the angle that's opposite that, call it angle J, call it angle KJL, call it angle LJK. I'm just going to call this one angle J in this case. That is the largest angle. The smallest one is the one that's opposite the shortest side. JL is the shortest side. Angle K is the angle that is opposite that. And then one last problem for us to take a look at. I like this one. This is one that's going to show up in your homework assignment, or at least one similar to this. Rank the 5 segments from shortest to longest. Wow, interesting. Now, first things first, the diagram is not to scale. That 72-degree angles might not be exactly 72. That 36 might not be exactly 36. That 80 looks a lot less than 80. But we don't need to know what this looks like in order to figure this out. We learned a couple days ago that the angles in a triangle add up to 180. So I'm going to do 180 minus 72 minus 36 to figure out how big that angle is down there on the side. I'm just going to plug that into my calculator. 180 minus 36 minus 72. And that tells me that that angle is 72. Ooh, that's interesting. So 2 of the angles in this triangle are the same. That means the sides opposite those will be the same also. I'm going to put some marks on there to show me that. Those 2 segments are the same length. And then in the other triangle, I've got 40 degrees and 80 degrees. So I'll do 180 minus 40 minus 80. And that gives me 60 degrees. I suppose I should probably write this one was equal to 72. So my missing angle here is 60 degrees. So I'm going to look at the 3 segments over here. I know that EG and EO are the same. So if I'm ranking these from shortest to longest, EO and EG are the same. I'll put those 2 together. So those 2 are the same length. And because angle GEO is smaller than angle G or angle EOG, that means that the side opposite that, side GO, must be shorter than both of those 2. So segment GO must be shorter than both of those 2, and those 2 are the same thing, so I'll keep them next to each other. And then let's take a look on the other triangle. On the other triangle, segment EO, which we already figured out was bigger than GO, that is opposite the shortest side, which means that segment EO would be the shortest side on that triangle. I also know that EM is the longest side, opposite the biggest angle, so that must be at the end of this. And OM is opposite the 60-degree angle. 60 is between 40 and 80, so segment OM must be in between EO and EM. So I've got them ranked. GO is the shortest. GE and EO are in the middle next to each other. They're the same. OM is the next one. And then EM is the longest segment in this diagram. And that is it. The assignment that's due on Monday is going to take a look at the triangle inequality that we did in class on Tuesday. If you missed it, go back and take a look at the notes from that. And then also the side ordering that we did today. Good luck on the assignment. Make sure that you work on that. Just do it now. Do it right now. Get it over with, and then you can relax over the weekend, and we can take a look at some new stuff on Monday. Have a great weekend, and we'll see you on Monday. Bye-bye.